And there it is, Jimmy. Another volume by Cross Sections. This one has an e to the x in there. There he is, the curve. Y equals 4 e to the x plus 2. This is a normal e to the x. It crosses the y-axis at 1, which y'all probably knew, right? Y'all knew that, right? Now, this plus 2, means it's not going to be a 1 anymore. It's going to be a 3. The 4 multiplying to the x, the e to the x, just makes the function steeper. So I'm not going to change my picture. I think it's fine. Okay, and then we have our x equals 1 line. So we're just going to do a vertical line right there and then shade in our area. All right, so that's our area R. And it says that the x-axis and the y-axis are the boundaries. Okay, the solid of these cross sections are perpendicular to the x-axis. So that means our semicircles are like this. Now, I just drew one of them for a picture. Okay, now, if I'm looking at this semicircle, I can see really clearly that my diameter would be this function right here, because all the y values right there are at the end of this diameter. So that would tell me the length of the diameter. But I don't need diameter. I need radius, because that's what I use to find the area of a circle. And so I just divide everything by 2, and I got my radius. Ooh. Okay, so to find a volume, we need to integrate the area function. Now, because the cross sections are perpendicular to the x-axis, we are integrating with respect to x. So our area function, oh yeah, and we're integrating from 0 to 1. Okay, there they are. 0 to 1. 0. Okay, so there's our area function, and yes, my stews, there's a 1/2. Why is there a 1/2? Oh, that's right, it's half a circle. Not gonna lie, guys, I prepared this, and then I didn't put the 1/2 there all the way to the end. And you actually get this as your answer, but it's the wrong answer. I'm pretty sure. I haven't checked to see if my answer is correct. I got A. But anyways, I'm pretty confident I'm correct now, because that is the area of half a circle. We have to take 1/2 pi r squared. But we have to have an x here instead of an r. So let's go ahead and take that r out. Now, I'm going to take the scalar out, the pi over 2, the 1/2 pi. And I'm going to put in this guy because that's what r is, as noted earlier. Now I'm going to take care of this squared right here by multiplying it out. I'm going to show all my work over here, so you foos don't try to do something silly like distribute this 2 to each of these terms, because there's a plus right there. Oh my goodness, you calculus stew. So the first thing you got to do is distribute this 2e to the x, and I get 4e to the 2x plus 2e to the x. That is 2x because you add the exponents. X plus x is 2x whenever you multiply common bases. Then I do the other term. I get 2e to the x plus 1. And then I do my little simplification. And then I rewrite my integral. Oh my goodness. Look at us integraling. Okay, now, when you integrate, you can integrate each individual term. And we can set up an integral expression for each individual term. I ain't doing that. I'm shortcutting this foo. Now, because this has a 2x and e to the 2x, one way to integrate e to the 2x is to use u substitution to help you see what's going on here with this 2 and everything. But I'm going to take the lazy route on this one. Okay, to do the lazy route, I'm going to think about just e to the 2x. You all know what the derivative of e to the x is, but what about e to the 2x? Now we have a function inside of a function, and whenever you have a function inside of a function, you take the derivative of the outside function, and then you multiply it by the derivative of the inside function. So I would get 2e to the x, because the derivative of 2x is 2. So you have your e to the 2x, and then you have the derivative of 2x. Now that's not what I want. Okay, I currently have a 4e to the 2x, and I need to know what I would differentiate to get, not this one, but this one. So I'm thinking, since I multiplied by 2, that I could have put a 2 right here in front of it, and then I would get a 4, right? Right. So if I take the derivative of this, the derivative of e to the something is just going to be e to that something. And then the 2 is a scalar. He's chilling in front. And then I have to multiply it by the derivative of the 2x. The derivative of the 2x is 2. And so I get 4 e to the 2x. Awesome smiley. Okay, so that means the antiderivative of the first term is going to be 2e to the 2x. The antiderivative of this one is just going to be the same thing. I'm a glass. Yeah, that's right, because 4 is just a scalar. The derivative of e to the x is e to the x. The antiderivative of e to the x is just e to the x. Oh. Now I got to plug in the 1 and the 0. So when I plug in the 1, I get all this stuff. When I plug in the 0, I get all this stuff. And now I have to simplify. All right, so we get a negative 6 right there, which I'm going to add to this positive 1. Positive. Oh, no. And when I do that, I get this. Oh, and there's my answer. Oh, my goodness. Oh, wait. Yeah, that's my answer. And I know it doesn't quite look like that because I have a pi over 2. But it looks to me like they distributed the 1/2 back into it. So if I didn't take the scalar out at the very beginning, I'd probably get exactly what they got. But actually, in math terms, this is exactly what they got. I just have to manipulate it a little bit more. That's how you do it.